Hello, hello. Today is May 20th, 2025. This is SIG Node weekly meeting. Welcome, everybody. Today on agenda, we have a few items, but we also wanted to run retro for previous release. Since we're entering new release, we want to know what went well, what went bad, and what we can improve going forward. So Peter, take it away.
Yeah, thank you, Sergey. So I'm going to post in the chat the retro document. I'm also going to share my screen. So here we are. So we had an incredibly productive 133. I think everyone in the SIG should be incredibly proud of all the work that we got done. I did the count and I counted a bunch of times and I might have messed up. It's totally possible. But by my count, we were tracking 41 keps and we merged 33, which is bonkers, like double our former record, nearly double. And also with a really incredible merge rate. So we, yeah, everyone should be really proud. We did a whole lot. Yeah, so I don't have anything super concrete to go through other than I would love it if we opened up for just, thoughts and feelings about how it went. The only takeaway that I have, the one takeaway, which is we did a lot. And then I do have one sort of piece of improvement that I'll get to. But I think starting off, does anyone have anything that they want to talk about that we did well?
One thing I think we did well, it is a lot of time during the planning time, we basically started to prioritize and plan for the API review. At least, I think not just me and several folks and reach out to our API reviewer upfront and update some things, right? So that's kind of things significant change this time because we upfront to communicate. And also, I think we upfront, previous we also did, we upfront define about review and approval and clearly check about the author, how much of the time committed on those kind of things. So avoid of the unnecessary waiting, like the waiting for reviewer, approval, or reviewer and approval waiting for the author, and everybody's last minute send, right? So there are a lot of complicated of the design. I think we actually, from beginning of the cycle, we already just go through all the design review and offline or here online, and a lot of open question. I think author, owner, reviewer actually proactively bring to the SIG Node. We also proactively make the decision. So there are a bunch of things I think is quite different from the previous.
Yeah, I totally agree. We were really organized at the beginning of the release and actually generally through the release. I think I also want to call out, I forgot to mention this ahead of time. I think the KEP Wranglers was a success there where we had people, being attentive to who owned what and where the state of things were, and we're poking people at the right time. And I think that also helped us with your second point, Don, of having the reviewer and approvers know when their time to jump in were versus when the author's time was. And I know a number of Wranglers also helped at docs time, helping defining, helping the authors out with documentation. So that was also good.
+1 for KEP Wranglers. I think that this is totally something we did good. It's a good initiative. We should totally keep, in my opinion. In my opinion, there is also something that could have done slightly better about KEP Wranglers, but really it's a minutia, which I will save for later.
Totally, yeah. I can't see the hands because I'm only on one screen right now. Does anyone have any other thoughts, things we feel went well? Cool. Yeah, but I think we should be incredibly proud of ourselves. I agree with all of the points so far. There's been a lot of improvements with how organized we are, and it clearly shows with completing so many KEPs and completing such a high number of the KEPs that we committed to at the beginning of the release. So kudos to everyone. Now let's talk improvements.
Sorry, one thing I just remembered about previous release. I think we finally cleaned up all the bugs from being marked as critical for release, and now they're all in backlog, like if they not deserve to be in the release. So I think going forward, we can keep this up and make sure that we know which bugs we want to address in the release, which are critical and which are not.
So you're saying we did a good job of knowing which bugs were blockers versus were not?
We cleaned up bugs that were marked as blockers long time ago, and now they weren't. And like you go into release and like you have bugs that marked as priority short term, meaning that you need to fix it this release, and they definitely not. That was something we cleaned up.
Yeah, totally.
Regarding the things that could better, I think this is in the bucket of good on the road to become great. I think that to move the KEP wranglers to next level, we can use a bit more tempo, like call in the wrangler, calling the group of wranglers, calling, okay, deadline incoming, which we kind of did, and we did, but more like structured, because in the past cycle as a wrangler, which I keep want to do, sometimes I felt, right, is deadline looming already, and I would like to be a bit more proactive. So that could really help to make next level. It's something that I'm not really sure I could improve, but some tuning in this area could really make this sub-initiative go from good to great, in my opinion.
I totally agree. I think, as a follow-up to, having a retro on the Wranglers, I think we did a much better job this release than last release of keeping the Wranglers' attention span and everyone, like KEP authors and reviewers' attention span for docs. We had many fewer docs PRs languish as we were approaching docs deadline, but I do think that we can still continue to improve there, because there were a number of last minute docs PRs that we needed to be reviewed from a technical perspective because they came in late. So I think something that we've historically struggled with is keeping our attention span post PR merge, and making sure that we're remembering that there continue to be deadlines after code freeze and keeping on top of them. So I would love to see us sort of more proactively handle documentation, so I don't have someone like, Kat or someone else from the docs team poking me saying, you have 10 outstanding documentation PRs that haven't been reviewed yet.
Big +1.
Last minute things perspective, I think this release we had quite some, more than usual test failures just before the release. And I didn't review it recently, but it may be because we didn't categorize tests correctly into the proper buckets, and I don't know. We may need to look into that, like why we get them last minute.
Totally. Any other improvements that we feel like are worth mentioning?
Keeping project board up to date would be really nice. So,
yeah, definitely. I personally struggled keeping it up to date. And even like I was not terribly diligent about putting the KEPs into the correct buckets, and I had to do a lot of revision in the last week or so changing things from not for release to removed because they mean slightly different things, and it helps, I think. So like something I'm taking away from this release is like being more diligent about knowing when a KEP was dropped from the release so that we have more accurate sort of like time series of like what we committed to versus what we knew we weren't going to do versus what we were actually able to get done. And I think doing that, keeping track of that during the release would also just help generally. Great. Any other last thoughts?
Surprisingly little feedback. So we did a lot and such a small feedback, meaning that we probably did something right.
I think we did a lot of things right. I think we should all feel incredibly proud of ourselves. And I honestly, maybe we might have hit a record for the project for number of KEPs per release. Like I haven't found any evidence that anyone's ever done anything done this much. So yeah, I think that we really, you know, there are definitely some things that we should fine tune, but I think we're drastically, we're like, look, this trajectory is just amazing. So yeah. Well done, everyone. Thank you for all your work, and looking forward to a productive 134. It'll be a hard release to follow. With that, I will yield the floor to Don, Sergey, and Anu talking about this container stop stuff.
Yeah, past meeting I briefly made an overview of in-place restart capabilities that we want to enable on Kubernetes, and Anu here is ready to present like how we prototyped it and like what kind of difficulties we met with. So Anu, if you want to take over, I made you co-host so you can present.
Okay, is my screen visible?
Yes.
Cool. Yeah, thanks, Sergey, for introducing it last week. So just to briefly summarize why we need this feature and who the target audience is. For large-scale distributed training jobs, if a single worker fails, the current mechanism of the underlying framework requires all these workers to restore the latest checkpoint and resume training from that point. So what that means is we're, in Kate's terms, we're going to restart all the workers on all the hosts. So if you're running as a job, what we've observed is restarting all the workers at scale becomes challenging because we have to terminate all the pods, delete them, recreate them, and then reschedule them onto new hardware. And ideally, instead of doing that, we want to restart the pods or the containers in place on the same nodes instead of terminating and rescheduling them. And currently there's no mechanism in K8s to achieve that. So the goal of this feature is to get there. And the reason we're using JobSet is, well, we wanted to try it out in an API that a lot of customers use for large-scale ML training. So JobSet seemed like a good place to test out this feature. So I'm just going to talk briefly about what our JobSet proposal is and what some of the hacks we're using are and why we want a couple of these KEPs in kubelet, basically, and like a container failure policy to address them. So our workaround or the problems we're trying to address in JobSet is when a single worker or container failure is detected, how do we restart it in place? And then how do we also signal to all other workers in the same job set that they need to restart as well? So currently the implementation of the JobSet controller is any worker failure causes the associated job to fail, and then JobSet controller goes and recreates all the jobs in pods. So it's not an in-place restart. And our proposal to modify this is we will ask the customer to configure their training workload as a sidecar container with a restart policy of always, so that kubelet will restart it on a failure. And we also have to make sure the job's back-off limit is something arbitrarily high so that worker failures don't trigger the job to fail, which will cause JobSet controller to recreate everything. Additionally, we are going to run an agent container that watches the sidecar for failures and success. It handles worker failures, and it also handles restarts. That's sending a kill signal to its associated sidecar container if a restart is needed. And then we're going to maintain this restart state somewhere. So we picked Redis or Valkey. Yeah, we're just using that for our state maintenance. And then there's a link here for a sample job set spec that you'd have to configure to get this to work. So I'll talk about why we did some of these workarounds. The first one, where we're using the sidecar container, ideally what we want to do is use a pod failure policy that ignores pod failures that occur due to SIG kill with a pod restart policy of on failure. So this will allow kubelet to restart the containers without counting against the job's backoff limit. But we have a limitation where currently in the job API, it enforces that a pod failure policy can only be used with a restart policy of never. So to work around that, we have this sidecar container hack. And then to address that, Sergey has a KEP that he's proposed with container level failure policies. So we want to declare failure policies at a container level to ignore certain error codes as non-failures and then restart the container, even if we have the pod restart policy set to never. So this would be an example. And then if we did this, we'd be able to use a regular container with the restart policy on failure instead of a sidecar, and we wouldn't have to set a very high backoff limit. Sergey, I don't know if you want to talk a little bit more about this proposal.
Maybe Yuan is working on that. Yuan, do you want to speak about it and how we had a conversation with the job set people today?
Sure. Yeah. Yes. We have this proposal in CAP. It's open, and yeah, we basically want to say that if the pod restart policy is never, the customer can still ignore a few exit code so that the container can be restarted in place instead of failing the pod. Currently, the job set only looks for the pod level condition. So if the pod goes to fail, the job set will tries to recreate the pod and reschedule it somewhere else. So with this container in place failure policy, the container can restart in place, and it won't trigger the job set to reschedule the pod. And yeah, with this setup, we don't need any change from the job level.
Yeah, this is a proposed API, and with this proposed API, we will not need any changes on job set level because job set will see the pod as a restart policy never. Yeah, Kevin.
So for the container restart policy, will there also be support for conditions as there is for pod failure policy?
So longer term, we want to extend it, those policy rules for more and more conditions. Right now, the proposal is to start with small, and you see how names are designed after pod failure policy names. So likely we will want to extend it to more conditions like that.
Okay. Thank you.
Yeah, Bruno?
So I think it's a bit confusing from reading the spec where you see at the pod level it's saying restart policy never, but you go down and say, oh, ignore that when this happens. Instead, have we, as an alternative, considered where we come up for a different term where containers could restart instead of saying never at the top level?
Yeah, this is an alternative proposal, have new restart policy that basically indicate never, but called differently, like conditional. And then
yeah, something like that. Yeah.
So that is another option that we may consider. The argument for never with ignoring some of the failure policy is that we already have sidecars, and the sidecar behavior is basically restarting all the time, even if pod failure policy is never. So we already breaking this promise that we had before that no containers will have restart count more than one if restart policy never. So we already breaking that, and I thought that it may not be the biggest problem semantically, like people will understand it. But yeah, that's another possibility.
Yeah, but I think the sidecar, the name itself indicates something different from regular container. Anyways, I think I like the idea. This is just done it on the API.
Yeah, if you can comment on a PR, it will be amazing, because we want to have this conversation, and sooner we'll have it and resolve it, sooner better it will be for implementation.
Okay, will do. Thanks.
No more hands. Okay, I'm gonna quickly talk about the other one then. So the other thing we're doing is we're using the container runtime interface APIs to go and kill the worker containers, because there's no other way to do it via kubelet. So this requires mounting the CRI socket as root, and also we haven't tested using this API at scale. So ideally there should be a way to kill a container from another in a different manner. So to address that, Sergey has another KEP about pod self-orchestration, which is a way for one container to tell another to restart while ignoring the restart policy. Yeah, Sergey, do you want to talk a little bit about this one too?
Yeah, I created an issue for that, and issue refers to document. We started with Eduardo from NVIDIA. I know if Eduardo on the call right now. So the idea here is, I mean, we need to allow one container inside the pod to control something else in this container, and to do that, we don't want to allow containers to interfere directly with other containers. We want containers to tell kubelet what to do. So there will be communication channel from kubelet to container and back, beyond the liveness props and healthy props. It's just it's a new communication protocol that will allow, like today, it will allow one container to kill another container. In future, it may be way more. And we started writing about it in this document that it's linked from a CAP. So yeah, we didn't find any other alternative how to kill one container from another container. So I believe that like setting foundation for this kind of self-orchestration is something that we will start with in this CAP. Yeah, Peter?
Yeah, two questions. One of them is, I mean, why, because this container is in the same pod, right? So why can't it just have a pod level PID namespace and directly kill the PID, kill the container itself?
Yeah, I think Anu has a lot of answers. Like she tried every possible scenario, like how to kill something.
Yeah, so we did consider killing the process instead of killing the containers by sharing the PID namespace. But I think we struggled with identifying like the correct process to restart. There's no like easy way to map which process exactly is the one that the sidecar is or the worker is. And I think we came across some like third-party tool that does a conversion or a mapping, but there's no like, I don't know how well tested that is, and it didn't seem to be like a native way to do it in Kubernetes. So I felt that the container approach was safer and more reliable.
And also those jobs typically nowadays have multiple sidecars. So there's like some networking sidecar for GPU and then some monitoring sidecar. Yeah. So detecting which processes to kill, it's not an easy task.
Yeah, that makes sense. I mean, yeah, if it can. The other thing that I was thinking about is it really having a whole fully fledged API or like having a streaming interface between the kubelet and a container seems like a heavier hammer than we potentially need. Like, have you considered also just an API that the kubelet exposes, like, you know, and you can connect to the HTTP endpoint of the kubelet, you know, saying kill this container in this pod, and reference them some way, like by name or something like that. Similar to how you can like attach the logs of a container through the kubelet API. Obviously that wouldn't cover potential future use cases, but I also kind of am of the opinion that we should maybe make it more targeted for this specific case instead of a more general thing.
So I think one option we tried in the spirit of what you suggested is using liveness prop of one container point to another container. Anu, do you want to talk about that?
Yeah, I think we tried that, but I think it was a little slow. I think that was the bottleneck for us, because the point of this feature is to make the throughput as quick as possible or the job set recovery time as quick as possible. And I think doing the liveness approach was much slower than what we benchmarked.
Yeah. So slow is one, and second is you never know whether it happened or not. and with a channel to communicate, the hope is to not only tell that you want to restart something, but also know when it happened.
Yeah, it's an interesting subject. I'm a little concerned about using the API machinery, client Go command APIs on even more streaming activities that the container runtimes have to implement as a server for kubelet. I've been trying to rip that out, and it's not easy. So yeah, as Peter was saying, a more formal API would probably help. We could work on the performance of it.
Yeah, I really need to put this down in writing. I have a little bit, like, few things to polish, and I will send a cap, and we can continue conversations there. I definitely, yeah, I will try to list some alternatives, like what alternatives we can have for smaller set of APIs and maybe like more straightforward. Thank you. Good feedback.
Yeah. Okay. Thank you. That's it for me.
Okay, with that, we have a next item. I'm looking at the agenda document. Kishan?
Hey Sergey. Firstly, thanks to everyone who has reviewed the node resource hot plug KEP so far. So we have a few findings with regards to how we'd want to update the score adjust value of running containers. So this had been an open discussion both from the container runtimes side of things and in the KEP, because I think there are a couple of features that already exist with regards to in place pod vertical scaling and node resource hot plug, where we typically update the container memory request and the memory capacity. So this would in turn affect the score adjust value every time we perform a resize of the container or the node. So we took these findings to the container runtimes. Basically, we raised a PR in Open Containers 1C to check if we can probably have a way to update the score adjust value for running containers. But I think the idea was shot down by Kir. Basically, he said it was not a very good idea to update the score adjust values, because it's basically the init process that spins up the the other dependent processes that run inside the container, and updating the score value for the init process would typically not cascade the values to the children process, and that would lead to an inconsistency. But at the same time, in the issue, I think we were told that if we had to fix a certain value for the memory capacity, that ratio would probably stay the same regardless of whether we upsize or downsize the node. So that would typically not require us to recalculate the score adjust value throughout. So yeah, that leaves us at a point where we are fixed. We are in a fix between choosing to update the score values or not updating them. So yeah, I just wanted to take the community's thoughts and feedbacks on the same.
Yeah, I think I might have been one of the people to suggest we update the score. I mean, because in my ideal, like a node hot plug event, we basically reconcile to a state that is as close to what it would have been if we had started with that memory or CPU in the first place. But I don't necessarily, I mean, it is a little bit tricky because then the pods will be weighted differently against each other, pods versus like that are created before versus after. I do know there are some cases where the OCI runtimes do loop through all the processes within the container C group to do things like in a kill, they'll recursively kill the processes, I think. So I do wonder if there could be appetite for doing that. I mean, obviously it's racy, and there's room for Toctow races and stuff like that. But yeah, I don't know. I mean, I don't think that it's a hard blocker that the score is reflected in the new values if it's documented well, but I can imagine that there will be weird bugs that happen in the future if we hot plug and then different pods are compared against each other to the killer differently and thus like prioritized oddly. So that's something to consider. But I don't necessarily think that we need to have it if it's fully being blocked by the OCI runtime maintainers.
Right. I think there is an API to update the values, but it certainly does not affect the score adjust value. I think that's the only thing that's skipped off, and the rest of the fields are updated. So I think at least at this point, we do not have something very concrete to choose between updating or not updating. But yeah, I think Peter, you just mentioned your points that it could be documented very well about the limitations of having of not having to update the score adjust or having to update the value. So yeah, I think that explains. But if there's anyone else that could probably share their opinion, I think I'd be glad to hear a couple more opinions on this.
I agree with Peter. I think I personally think about we need to consider this with this in-place pod resizing feature, right? So we need to think about how we calculate, and fairness is quite important, right? So fairness, the people will leverage those features and also respect the quality, the QoS. That's kind of the things, the fundamentally the things. But how to? But I also don't think about this is a blocker for in-place pod resizing. This can be enhancement or later, right? So, but let's just talk about the reverse of today's the formula, how we calculate, and then have the proposal, and then we can continue discussing. But I don't want this block of the in-place pod resizing. But definitely this could be enhancement. We come back. If we could achieve, we agree, achieve of the new formula and the policy, that's wonderful. Yeah.
Yeah, thanks, Jan.
Okay, if there is no more comment on that, go to Itamar.
Sorry, I think there just one other quick comment on that. Sorry.
Okay, no worries.
There was a comment that Kerr made basically as an alternate proposal for like how one could do this, which would involve like changing the way that we calculate score generally for all containers. I think it's worth exploring. I think we run into compatibility issues similar to how, there was a conversation of how to handle, I even forget the C group field, the way that we calculate some I don't know, Itamar brought it up a couple weeks ago, but basically we would have to change the way that we calculate score for all containers, not even just ones that are being resized, but I do think it's worth considering. So I'm going to throw that out there and maybe we can munch on that and then come back to it.
Yeah, sure, Peter. I think, yeah, we can try looking at that aspect which Keir suggested. Thank you.
Hey, Itamar, do you need sharing permissions or are you fine?
No, not really. So hi, everyone. I just wanted to raise attention to this issue that I opened. So to summarize it very briefly, I think that there is a problem with in-place resize from the aspect that it basically breaks out of tree quotas. The reason that I think it's really problematic is because basically we have the pod scheduling readiness, and all along the way it was documented very clearly that one of the major use cases is to allow out of tree quotas, and this made total sense because back in the day, all pods, all entities that require resources needed to be scheduled. So if you had a scheduling gate, that's it. You could implement your own quota manager. With in-place resize, this no longer remains. I have a very simple example just to demonstrate it here. So yeah, there's a quota pod being scheduled. After it's being scheduled, the out of tree quota manager just doesn't have a chance to really reject the insights. So yeah, this is a problem for Q as well, I know, but I think that it's a much severe problem for AAQ, which is application aware quota. Basically, it's a complete replacement for the Kubernetes quota, with a few additions. Yeah, so just wanted to raise attention for that. I think this problem is solvable. I think there are multiple approaches that we can take to solve this pretty easily. Yeah, and that's what I wanted to raise.
I have a question. I mean, do you think that this would be a blocker to become GA?
Not necessarily. I'm open to discussing doing it in a separate cap. But if we can, I think it's much better. I guess it depends like how complicated it is to support that. But yeah.
I think Wojciech basically already left a similar comment on the issue, but I think this is part of a larger problem around the scheduler and mainly the scheduler not seeing the in-place resizes, and kind of also a whole related nexus of problems around third-party schedulers and how those interact with the core scheduler, and the separate resource quota systems. I don't know the details of how the third-party quota works, but if it goes through admission, it could just intercept the resize request like the way the built-in quota manager works. But I think there's we need to think about kind of longer term, like what is the relationship between the kubelet and the scheduler, and how do we solve this larger class of problems? Another related one is there's a race condition between the scheduler and the kubelet, where if a pod is being scheduled to the node while a resize request comes in, that can end up with the pod being rejected in kubelet admission. And so we've kind of been talking about some different ways of fixing this. I think Wojciech's working on some proposal, or at least kind of looking at this problem a little more holistically. So yeah, I don't have any short-term answers, but wanted to give that context. One thing I am wondering about is if we need to push the resize decision up into the scheduler. So one of the plan changes in 134 is we're pulling the allocation logic out of the pod sync loop. And so the kubelet can look at all of the resizes and properly prioritize which one should happen next. And that's going to happen out of the pod sync loop. But I could also imagine pushing that allocation decision all the way up into the scheduler. We would have to add allocated limits to the pod API, but then basically the kubelet would only ever run based on the allocation, and the scheduler would be responsible for doing the resize in that case. So just a couple ideas there.
Yeah, thank you, Tim. Well, one thing I want to just emphasize, at least for my use case, is that I'm more interested of the use case of a running pod that has been scheduled and is running and is just being resized. So the race condition is a concern, but at least from like my specific use case, like this is not the major.
I just want to comment, just like echo what the team said. Those read conditions, they are for a long time. We read those conditions, potential conditions, for a long time. It's just because it is not obviously after we introduce the in-place pod resizing. But even we are not that in-place pod resizing is the good feature. Like you just mentioned, you actually see that risk condition, but you honestly you want to work around because that's really powerful feature for your workload for user, right? So that's the thing. So we've been call out this, at least I've been call out this from day one. This is why in-place pod resizing for take those many years, because we try to figure out how to, but then we realize if we don't move forward on the node side, people won't realize how severity this it is until we move forward. Like the first 6 years couldn't move forward. As finally we move forward, everyone understand the problem, and then this is actually help on the users. So that's kind of that's the strategy how we attack this problem. Since a year ago, we just basically just okay, let's just move forward. Let people have them understand the problem more deeply.
So for the queue side, I guess my main concern will be like, where does in-place pod resize like roadmap look for extended resources? Because I think this is a much more concerning issue if people are able to get more GPUs than like what they requested on a node, but I don't know where that work is at the moment. In-place pod resize of extended resources.
It hasn't started, but it's probably one of the next things we'll look at.
Yeah, because that's kind of where I'm thinking. I mean, yeah, for Q, it's definitely a way that people are going to they could get around it. I mean, I guess we are talking about ways to react to it in Q. I have a separate issue I created once Itamar posted this one. I was also thinking about this too, but yeah, I don't know. I guess I have to look at how the resource quota handles it, and kind of think a little bit more about what we could do on the Q side to react. I guess the one idea that I was having, at least with the ohm score idea, whereas like we have kind of like a maximum limit that you can resize to, and then we kind of, I don't know how that would work, but wondering if like there is a more declarative approach for resize, that we like take the worst effort case for some of these cases. Was that ever discussed with in place? Like, I guess right now, theoretically, what our upper limit of a resize is the node limits, or the up to the higher limit of the pod. Anyway.
Sorry, I think I didn't quite understand
I'm wondering, what is the upper limit of a resize? Like, what is like the physical limit that somebody is actually allowed to resize a pod before like it's rejected anyway?
So there's this notion of infeasible, which is a resize that will never get accepted, and that's going to be limited by the node capacity. Well, the allocatable capacity specifically.
Okay.
And then the available capacity will be what can actually be accepted immediately without it getting deferred.
That makes sense. Okay. Yeah, then I guess that wouldn't be as useful. But yeah, I was wondering if there was more like an API to specify for some of these resizing pods. That's like an upper limit that, like for Q, we could admit, take the worst case scenario and admit, and then let a resize happen. But I don't think that API is there, or it's definitely not there. And then for ohm score, like calculating the ohm score based off of the worst case scenario. But if the worst case scenario is the capacity of the node, that doesn't really work.
Yeah, but Kevin, I mean, what you are describing, perhaps also the controller that it will actually do the patch command can take care of those things, or?
For Q?
I mean, resource resize, it doesn't happen out of the blue. Someone needs to patch the pod. So,
yeah.
So what you are describing, it should be also responsibility of whoever or whatever is doing this resource resize, correct? Or?
Yeah, I'm thinking out loud. I haven't spent a lot of time looking at the in place. Yeah, I mean, like right now, I think the challenge is people could resize whatever they want.
Yeah.
And in Q, like I think like the worst case is we would just, if people are using Q, we would just require the disabling of the resize. resource to avoid this. But
yeah, that's a good point. And I think in Slack you have mentioned it. I don't remember if it was you or someone else, but actually operators that they were since resource resize, now it has been refactored and some more things are now present in the status. So operators needs to be updated to take advantage of this extra information that exists, I believe. So it is good that you mention it, that we need to update also whatever it was using this.
Yeah, that makes sense.
But I have a question. What you're describing, does it also consider, do you also think about hot plugging and all these things, like things that are being discussed in the DRA, where CPUs are added and these kind of things? Is it also in scope of what you are thinking of, or?
I haven't really thought about node hot plugging, to be honest. Not that much details.
Okay, sounds fair. Thanks.
One more chain of thought here, like queue, the queue operator, it knows the capacity of the various queues, right? Cluster queues, local queues. So should we require that is the entity which is actually allowing the resize request to go in or not, depending on how much capacity is remaining, rather than it reacting to an update? And that will be a way to avoid callouts back to these queue-like systems.
Yeah, I will have to think more on the queue side, how it react. Some ideas are just evicting, like if there's a resize, if it's possible to detect that, we evict and then have the readmission happen, which just kind of undo it. But
yeah, instead of like reacting, right, we just make everything go through the queue operator, and a resize request should also hit it. So it admitted a workload, which now needs to be resized, and it can reject it right away if it knows there's no capacity in that virtual queue to update that. Instead of someone going in and directly messing with the workload and queue reacting, maybe we invert the problem. So that will be the same with horizontal scaling as well, right? You have some workloads, we determine there's a horizontal scale up required, and it will come in through queue, not the other way around.
yeah, that's kind of a pretty large change for queue, though. Queue, the idea would be that someone interfaces with a pod, and then queue is always going to react to whatever a workload is doing, not the other way around. Because queue isn't it. That's kind of one of the patterns there. So we could discuss that one offline.
Yeah, I think worth considering, I think, as an design approach there.
Yeah, one last note from my side is that I don't really know too much about Q, to be honest, but with regarding to AAQ, the whole shtick there is that it does not rely on webhooks, right? Because webhooks are raceful and for other problems, and basically it uses only scheduling gates, which it could then remove at its own pace. So yeah, just wanted to say that. So dealing with all using just admissions to solve this would not be a solution to AAQ, at least. Thank you, everyone, for the discussion. Please comment in the issue if you have any more thoughts. And yeah, thank you.
Great, thank you. Next up, Philip, for Node Lifecycle Working Group update.
And we only have 6 minutes and 3 topics. So if you really want to speak about your topic, please ping us in chat and we will try to fit you a couple minutes.
Yeah, so we had another discussion about the priorities and exit criteria with the group. And to sum up, there is a general concern that we will be spreading out ourselves too thin if we try to cover all the ground and all the caps we have even looked at in the proposal. And so like we would like to scope it tighter, so to basically so we can rally around this common problem that like we can acknowledge, and for the other topics we would still like to give ground like to for presentations, etc., but it will be not of our top priority. So I will put a link to the agenda, so where we discuss the prioritization in the CAP. So yeah, like I would like to ask if of your opinions.
Great, thank you. Yeah, let's continue the conversation on the community PR then. I guess Marcus is moving to next week in Dixie. I answered that question. So did we have anything else we wanted to talk about?
Marcos just said out of next week and want to have the demo. Do maybe 4 minutes can do the demo. Okay, never mind. Sounds like he just left.
Yeah, maybe. And something to note for next week also, I think we are approaching KEP planning season. We don't necessarily need to go through all of it next week, but I think we'll want to start getting organized around that because the deadline's coming up in a couple of weeks and we don't want to fall behind. So I'll probably put some amount of time at the beginning for KEP planning, and we can maybe start getting a little organized this coming week. But just as a note for people who are potentially want to give a demo or something. 'Tis the season. Given that, I think we can adjourn this week. Thank you, everyone, for joining, and we'll see you next week.
Have a good one. Thank you.
Thank you. Bye-bye.
Thank you.